Hey everybody, this is off of the final learning packet. I put a video on it, took care of the graphs, comparing the histograms and stuff already on YouTube, so I'm not going to cover that. What you're going to need today is make sure you got this formula sheet in front of you. Also, if you can, pull Desmos up on a browser, because we're going to use Desmos quite a bit today. And I'll try not to let this thing go too long. Let me set a timer here. If it does, I'll make it into two parts. There we go. Okay, first thing we want to look at, this is the formula sheet that you would have had in front of you if you had been taking the SOL. And pretty much the only two things that we really use heavily is a rectangular prism and a cylinder. And notice that you have a V and an SA on each one of these, and those stand for volume and surface area. Okay? So when we're looking at volume, this thing reminds me of a fish tank. Volume would be how much water it would hold. And surface area, if you had a lid on it, would see how much glass it is. Okay? And same thing over here for the volume and surface area on a cylinder. Say it's a soup can, how much soup can it holds volume, surface area. If you wanted to wrap the whole thing in paper, how much paper would it take on the outside? Okay? Down here I put in a couple of things to remind you what they are, length, width, and height. There's your pi. We'll always use 3.14. R is a radius. Remember, radius is halfway across the circle. Diameter is all the way across the circle. And the H stands for the height. If you see these two little curvy lines, that means it's approximate, because pi is not perfect. It's just a never-ending number. Okay? Should cover all of that. Let's bounce over here. In this first sheet, what I did was I pretty much solved the problem for you, except the final answer, and we went through each one of them. This figure right here is a rectangular prism, has a length, a width, and a height. And notice I put the LW and the H. If you get those mixed up, it's not going to make a bit of difference. You could call that the length and that the height. As long as you have all three of them in there, you're fine. So if you look over here, this first one, volume, we look at the formula sheet and it says LWH, which means we're multiplying the length times the height, or times the width and times the height. Let me get my pen working here. So what we're going to do now is just go ahead and multiply those and answer the question. And if you don't have a calculator in front of you, you can just use Desmos. So when I multiply those, I end up with 60. Now the key to doing these geometric problems is the ending. 60 what? Well, this says inches. But if it's volume, that means that it's cubic inches. That means that you could set 60-inch cubes inside of that. So we'll put a 3 right there, 60 inches cubed. It could be also written as 60 cubic inches. Either one of those is fine. Okay, let's go over surface area. If you notice, I took care of all my multiplication first, and then the addition would come last. And Desmos will do that for us. That's why it's so great. And we'll go ahead and add 40, 60, and 12. We end up with 112. This unit is inches also. But now this is surface area. So it's on the outside, and it's two-dimensional, so it would just be 112 inches squared. It could also be written as 112 square inches. So we always got to have something on the end of these geometric problems. Let's go down. I think I got two more. Now it's got the cylinder, and we'll cover this cylinder probably in the next video, but I'll go ahead and show you these two examples. Notice I put some notes for radius and diameter, halfway, all the way. Diameter equals 2 radiuses, or 2 times the radius, and the radius is half of the diameter. Okay? So in this case, you have a diameter of 9, which in all of our formulas, we don't need diameter, we need the radius. So all I did was busted that in half, and I have a radius of 4.5. Notice in this formula, you've got to square a number, which is your radius, and you always have to square that exponent, or take care of that exponent first before you multiply the rest of this, okay? So in the third line, all we had to do was multiply these three numbers, which ended up being 1,080 and 9/10 centimeters. And since it's volume, it is cubed. Okay? Or you could have written that as cubic centimeters. Okay? Over here, surface area, a little bit different. You've only got one exponent. So what I do, when I'm doing these by hand, I take care of this exponent. And when I take care of that, I also go ahead and multiply this side. So I took care of my exponent, which is 20.25, took care of this side, got it out of the way. Now multiply those, and then I add the last two. Desmos will help you out a whole bunch there. You won't have to fool with a lot of that. 607.6, and it's centimeters. Since it's surface area, it is squared. Okay, so that's just kind of an introduction. If you get stuck on something, it's good to come back to these to double check how to do them. And I know that's a quick introduction, but you've got this in front of you. So if you need it, go back to it. So jump into probably the easiest one. Oops, sorry, I got some student notes here. I wrote you a few notes for each figure. I'll let you read through those. Down here, we're going to have some word problems later, practical situations of when you're going to use volume and when you're going to use surface area, because we got to be able to tell those two apart. Okay? And over here, probably the easiest part of the sheet, that's why I didn't ask you to just do the odds, because when we're doing volume, if you look at your formula sheet, the formula for the volume of a rectangular prism is nothing more than, and I'll go ahead and write it up here, if you'd write it on your page too, volume equals, and it's length times width times height, and that's all it is. It's just multiplying. And so, to be honest, if you get these mixed up, it will not matter a bit. You could just choose the first number you see, multiply it by the second one, multiply it by the third, okay? Don't worry about which one's the length, which one's the width, which one's the height. It'll be fine. Okay, so in the first one, the numbers we need to multiply are 7, 12, and 5. Pop that in Desmos or in your calculator, and you're going to end up with 420, sorry about the clock, 420 centimeters. Pull my page up a little bit. And since we're talking about volume, it's got to be cubed. Okay, that's how easy these are. They're just multiplying the three numbers. I'm just going to do 1 through 3, and I'll leave those others for you to practice with. Over here, all I'm going to do is take 8, multiply it by 15, and multiply that by 18. All at the same time, I get 2,160. Oops, pen went crazy. 2,160 centimeters. Oops, no, that's not centimeters. My fault. Isn't that inches on this one? Yep. 2,160 inches cubed. Okay. On the third one, again, all you're doing is multiplying the three numbers. 16 times 7 times 10. And that is 1,120 feet cubed. So I think with those three examples that you could probably pop through the rest of those pretty simple. Just multiplying the three numbers or something of that nature. It's no big deal. If you have any issues with that, shoot me an email or anything like that. What I think I'll do is in this one, it's under 10 minutes. I like to do that. And then the next one, I'll jump into the surface area of the rectangular prisms. Don't forget, there's your formula sheet. You could throw this in Desmos. You got your notes, student notes on what they are, and a few examples. Okay, I'll catch you on the next one.